On ground, subject to strain and deformation, buildings and roads can be tossed around like toys due to ground liquefaction. Strong upflows of water and sediment can suddenly well up on building sites. Swamps and clay ground hamper construction work. Soft ground makes construction work difficult and continuously threatens the stability of buildings. However, conventional technology has not yet been able to overcome the challenge of soft ground. In view of this, we have created a totally new approach to ground. The D-Box technology we have developed is able to reinforce ground even in places formerly considered to be difficult or impossible. Even extremely soft ground can be reinforced with D-Box technology alone. In addition, the D-Box also has the properties of absorbing and reducing vibration. Now, let's look at the theory and method of using the D-Box LS series. D-Box is an abbreviation of divided box, and this is a registered trademark. This box-shaped bag is divided into compartments and restrained. When used, it is filled with sand or gravel and closed firmly with bands. The greatest feature of the D-Box is that it takes this shape when lifted up. On the inside of the bag, there are 4 truss bands running from the corners to the center. These are tied together with the lift band in the center and lifted up out of the bag from the center point. The soil particles inside the bag are confined and compressed. This structure, which at first glance appears simple, gives the D-Box very unique functions. The D-Box is lifted up by a lift band at one center point, and due to its internal restraints, it retains its basic box configuration. What's happening inside the bag? By lifting the bag up, the soil particles inside are strongly compressed by tension of the outer bag and the internal truss bands. At this time, powerful friction occurs among the soil particles, and the entire D-Box generates massive compressive strength. The power of this friction is maintained even when the D-Box is placed on the ground. When external pressure increases, this friction becomes even more intense and the strength of the D-Box increases still further. When the D-Box is lifted up, another important change occurs. The bottom surface forms a conical depression. This depressed area has a major role when the D-Box is placed on soft ground. This is an experiment simulating ground liquefaction. We compared the cases of concrete foundations and D-Box foundations in terms of behavior during an earthquake. When the model house foundations are concrete, it tilts over and submerges. However, with D-Box foundations, it does not tilt over but just subsides into the ground slightly. Why did the concrete foundations tilt over and submerge? Seismic shaking causes the space between soil particles and the ground to decrease progressively, and so groundwater is forced to rise up to the surface. However, the movement of water is blocked by the concrete foundations, which are not permeable, so water builds up under the concrete and the ground loses strength. In addition, soil particles flow out with the water from under the edges of the concrete foundations, and it tilts over and then sinks. However, in the case of the D-Box, the water and soil particles gather in the central depression at the base. Then, due to the permeable property of the D-Box, only water is absorbed, blocking the passage of soil particles. This minimizes the subsidence and reduction of the bearing capability of the ground. Looking at an experimental mock-up, there is no change in the D-Box due to the seismic waves. However, the concrete sinks. When seismic vibration stops, we can see that the D-Box has absorbed the water around the box, but the concrete has sunk. And now, let's look at some applications of the D-Box with these functions. This high groundwater level site was excavated, creating a difference in groundwater with the surroundings, resulting in a piping effect leading to ground liquefaction. The sand stratum was about 20 meters deep, and if concrete plates were placed here, they would immediately sink and disappear. However, 5 minutes after installing D-boxes, they stabilized. There is only one layer of D-boxes here, and someone is standing on top of them. D-boxes are also used to strengthen clay ground. This is a swamp that is scheduled to become a road construction site. In places with a soft center area, D-boxes filled with sludge are installed, and then D-boxes filled with gravel are placed on top of them. D-boxes filled with sludge are squeezed internally using truss bands, and they are effectively dewatered in a short period of time. Depending on the purpose of the application, D-box may also use soft clay excavated on site during the construction process. Even on very soft ground like this, if D-boxes are installed, an excavator can be set on the boxes and perform work. In places where D-boxes are not installed, the ground remains very soft, and if a long rod is pushed in, it slides down with almost no resistance. In places like this, concrete foundations cannot be placed directly on the ground. If concrete is placed directly on soft ground, pore water pressure rises unevenly directly under the concrete. As a result, unevenness occurs in the ground strength, and the concrete tilts over and sinks at the weaker points. However, if D-boxes are installed on soft ground, due to the central depression at the bottom of the boxes, soil particles are kept separate from each other, and they form a temporary resistance surface. At this time, the pore water pressure rises directly under the D-boxes. However, due to the filtration effect of the D-boxes and the water drainage effect of the soil, the strength of the ground is progressively increased in the area under the D-boxes. If D-boxes are used, the following case is possible. It is necessary to construct a temporary road over a swamp, but the water is deep and it would involve very high costs. One area of the bottom of the swamp is excavated and the soil is banked up and used to make the roadbed. Then D-boxes are arranged on this. The work is only possible with D-boxes because they give support strength due to the improved upper ground layer. D-boxes are arranged on top of the soft banked up soil, and pressure is applied with an excavator. This rapidly stabilizes the ground because the pore water pressure directly under the D-boxes rises temporarily, and this drains off the water. Just 4 hours after this work has been done, the D-boxes under the gravel are once again compressed by an excavator. They do not move. They are able to withstand approximately 12 tons of pressure. The D-boxes are made of polypropylene sheets and bands, a readily available material. Material packed in is sand or gravel, basically, and also the soil from the construction site can be used when that match the purpose. An excavator is employed and the installation work is very simple. Moreover, the work time required is very short. Strengthening soft ground with D-boxes gives outstanding cost performance. In addition, the environmental burden imposed by the D-box method is extremely small. Problems such as hexavalent chrome pollution or ground alkalization do not occur, unlike when using concrete. Problems such as creating unstable ground due to blocking the groundwater flow and adverse effects of the natural environment can be minimized. We hope that the new D-box construction technique can assist you and your projects in sustainable development towards the future society.